Welcome one and all to the 7th episode of D&D Season 3. I'm Mike.
And I'm Zoe.
And today we're going to carry on with our enemies. So we had a few problems last time that we needed to solve. But there's also one thing that we've had for ages now that bothers me, which is the player keeps resetting in a ridiculous place, and that makes no sense.
Which is in the middle of the sea.
Yeah. So what we're going to do for now is we are just going to do something really cheap and basic. And in the game manager, we're going to allow ourselves to delete the profile. So create a public void. And go delete profile. Yep. Yeah. And for this one, we need to exit the player prefs. So go player prefs. Try delete all. There it is, delete all. Hit tab right away. Open, close round. Semicolon.
Why did it appear?
Because it was the first option. Okay, and now we need to basically request it somehow. So let's create a void update. There it is. Now hit, yeah.
Oh, I forgot about that.
Yeah, it does autofilling for you. And now here you go, if... How would you check if a key is pressed?
You go get button down.
Yeah, but you need a class
Input. Dot.
Get key down.
Get. Yeah, because we're using keys to move.
Well, I mean, this is just for debug. Open round. Now you need an enum key code. Dot.
Which?
And now you need to choose which key for deleting the saves. Probably the keypad minus is pretty good. So
do
let's.
I write that?
Yeah. So start typing K, E Y, P A D, M. M. There. Tab. Close round twice. Close round twice.
Oh. So that.
Yeah. Open squiggle. Okay. Save. And here you're gonna say delete profile. Yeah, open, close round, semicolon.
Oops.
Or select all.
There.
Okay, and now what we can do is we can launch the game, wait a bit.
Mm-hmm.
When it's launched, we're gonna hit minus, stop the game, launch it again, and it should start us on the... should start us in the scan, or not. Okay, let's see why this is happening. So this may be a bigger problem than I expected, but it should have something to do with the saving, right? So when do we save the profile? Hit Control F. Load default profile. Default attributes, player default attributes. These are in Game Manager. Let's go take a look. Spawn coordinates. That's the problem.
That's the problem.
So we got default coordinates that make no sense, and that's because they used to be there. That used to be what we had. How do we solve this? So this is not obvious, but I suppose it's fine to have them like this. So that means we need to go and look at our art, our maps, our entities, spawn point, open that. Whoops, that's the prefab, my bad.
Oops.
Textures, entity, map. Okay, so we still want to spawn on our little island.
Mm-hmm.
Therefore, we hold control. Release. It's gonna be there. If we lower this to 1, we should see the coordinates in the bottom left. 31, 46. Right. So we're gonna go and tell it 31. 46. Okay, now let's see if it immediately works. If it does, then we are not even saving, and it doesn't. So let's delete the saves, stop the code, open. Now we should be there. And we wait.
Aren't? We're in the fortress.
That's a bit odd. So let's take a
We're
look.
close to a
The
spawn.
player's coordinates are exactly correct. Okay, so that
Maybe the place is upside down?
possible, but doubtful. Maybe the 0 is somewhere else. So 3117 says here. Oh, it's backwards. This guy is upside down.
Oh.
Yeah, so this up here is 64, or 0 rather, and this down here is 63. So we need to do the opposite. Right? So 63 minus 46 is?
19, I think.
No, 17.
Oh yeah, it's 6. I was trying to do it in my head, and I failed.
That's okay. 17. Now again, we'll spawn in the wrong place first. Let's leave ourselves a debug log for when we delete the saves as well. So here, put debug.log open round,
Uncaps that.
open round, quote, saves deleted. So this is just debug for us. And now, if we hit play, we'll be spawned in the wrong place. We're gonna delete the saves, stop, play, and we'll finally be in the right place. So at least that's good.
Save deleted. There it is.
There we go.
Yay.
Right on top of the spawn point.
What if we need to spawn from the other one?
Well, we'll worry about that later, right? So now, we got the enemies spawning and they are looping in various directions, right? Our next goal is doing a few things. Well, first of all, this can't happen. The reason why this is happening is because we are moving the enemy with rigid body and transform. So the enemy still has velocity.
Yeah.
Okay, so when you move the enemy, now it won't move, but now it has velocity, see? So now it'll spawn there, walk up, and then fly in the same direction as before.
Yeah.
The reason why that's happening is that rigid body. So that's a fairly easy solution to this. We want to keep on moving the transform on this game will not have physics, generally speaking, right? In fact, we could even get rid of the rigid body. We may want to keep it for whatever reason, if we need to raycast or something like this, right? So what we're gonna do is we are gonna go to the prefab, enemy bomb. We're gonna open the prefab, and we're gonna tell it that it is kinematic.
Change it with no. X that.
Yeah, which means all of these are kind of pointless. But
Yeah.
that's fine. So it still works. It's just considered like a still object. So it should affect us in that we shouldn't be able to walk through it. And we're not, right?
Yeah.
But he's like a wall. So we're getting some jitter. Let's see now. It just moves us, right? The reason we're getting jitter is because we're pushing the transform again. Right? So, you know, this is an interesting conundrum. Oh wait, are we pushing that? No, I don't think so. Aren't we? Flop. Oh dear. The physics engine didn't know what to do there. But that's okay. This will never happen, right? If you get if an enemy hits you, you're gonna get hurt or whatever.
Yeah.
Right? So we're not gonna let
will shake a
we're
bit.
not gonna let this happen. But anyway, we've already fixed this problem. Okay. So all of these little bomb
Bombs are
fellas.
unpushable. They
Now
look like
we had another problem,
bombs.
which is you can see here, this bomb is walking really slowly.
Yeah.
The reason why it's doing that is because the distance it needs to cover is smaller. Also, it's actually entering the object,
Yeah, I saw.
right? And the reason why that's happening is because we're not putting the object far enough from the point of contact of the ray, right? Because it casts a ray to check if anything's there.
We could turn it so that it goes in that direction.
Well, sure, that's a level design solution, but I still want to be able to have shorter paths and still travel faster. So we've got a problem that regards math there.
Yeah.
Enemy spawner. What the heck? Where's the enemy? Huh? Where do we put the enemy? Open prefab. Oh, hello. Yeah, it wasn't in our scripts. I don't know why. But anyway, so set up, blah blah blah, ray as position, forward, wanted distance. Okay, there's the one. Wanted distance.
There.
Normalize patrol max distance. S position, ray direction, normalized time patrol dot distance. Okay, got it. So then we raycast. If we hit the wall, then we've got a hit point minus ray direction normalized times half. So half is the half size of the character. Let's leave it at times 1. Okay, save. No, just save.
Oh,
times 1 is stupid. You don't need to say it.
Good
right?
point, because it's not. It's
anything times 1 is always anything.
Yeah.
Right. So that should help us with the whole. It's half in the building, though it won't be perfect because if you have weird angles, right, you would need a different position. Now we could go by the normal. Okay, let me. I'm just talking now. You're not understanding, so I need to show you this. Image, canvas size. This is actually something that you need to learn about computer programming in general, which is the consistent attention to all of the possibilities. It's something you need to do as a developer. So let's add a new layer here. Now our situation resembles this. Wait, hit undo, Control Z.
Yeah.
Our situation resembles this. There's a wall, there's another wall.
Yeah.
Okay, so the bomb starts over here. Okay, and then it decides to raycast in this direction. Okay, it hits this wall. What we do is we take the opposite of this direction, this one, and then we put it there at distance 1. So about here. Now this could work, okay, but it could also still have a bit of this inside. How? I'll show you. So suppose that, for example, instead of having a bomb that starts there, you had a bomb that started here, okay, and it went at this angle. So really, really flush to the wall, but still at an angle. So suppose it eventually raycast hits here. Actually, I suppose it's a bad example. Let's do it a bit better. Let's even delete a little bomb. So I'm gonna go back and draw the bomb again close to the wall. Then here, and then I'm gonna raycast in this direction. Now you see I'm clearly hitting the wall here. Okay? If I now push back by 1, okay, the bomb is still gonna be partially into the wall. So now we need to start basically not making stupid decisions with our level design. But you understand why it's not ideal. Now, vice versa, you could, for example, have, let's see, this situation. So let's delete our bomb, put it back to where we had it, cast exactly in the same direction, or more or less. Okay, you find yourself in this situation, and if instead you decide, okay, I'm going to use the normal from the point of contact, which is this, and go over here, then you can put the ball here. Looks safer, but what if you had a wall here? All of a sudden you're half in and you're even traveling through it.
Yeah.
Right, so we have various other problems that we would need to worry about, okay? Because we're not making a super professional, super cool, advanced game. We're gonna solve most of these problems with our level design, okay? So we're not gonna make these dumb decisions where we can make, stupid, risky paths for our bombs. But still, we still may want to make shorter than normal paths, okay? So in that case, we are going to figure out what's going on with our distance here. So here we're getting where we are, and that's fine. Now actual distance is what we're interested in, which is this in end position. All right, good. So we got all of this covered. Now, why is our thing not working correctly? So here we're multiplying actual distance divided by wanted distance. And it should be incorrect. And here is why. So again, let's re-observe our mathematics just a bit differently. So
Yeah.
let's say we need to go from point A to point B. Okay? Now
Okay.
let's say in our second example, our point B is shortened. We're still
Yeah.
applying a lerp to go from point A to point B. Now suppose we're using speed 1 here to go from that point to from this point to that point. That means it'll take 1 second.
Yeah.
Right? Now, to get from this point to this point, we need to take less. Suppose it's at 0.6. Okay? Suppose it's at this distance. If it's at this distance, the speed here to get from here to here should be higher or lower?
Lower.
Why?
Because it's less.
But if you go at a lesser speed, okay, you
Mhm.
are going to get here even slower than normal.
Because you're going less fast.
We're lerping. Remember, you're
Yeah.
lerping. Lerping doesn't care about the distance. Okay? Lerping only cares there's a start point, there's an end point. It will
Yeah.
always take a second. So if we leave it alone, it'll take a second. This means that traveling to here will feel slower than traveling to here. So we need to speed up this. The problem of our math is that we decided to do this. We said actual distance, AD, which we
Mhm.
know is shorter, divided by, right, real distance, RD. Now, real distance is always larger than AD. This means we're going to have a smaller number as a result, which means we're multiplying this by, say, 0.6 in this case.
Yeah.
Well, which makes 0.6. So not only are we going less far, we're also going slower.
Mhm.
Okay? We did the opposite of what we needed to do. So here, instead of this divided by this, let's do the opposite and let's divide wanted distance by actual distance and try that. I'm not even particularly sure it's that clever, but it could work. So actual distance. Save.
Sorry about that.
No, that's my bad. Save.
There.
Okay, now let's give it a shot and see if that little bomb is now going to behave the way it's supposed to. It's lovely to have a small project so it compiles immediately. Unlike Thrusty Ship.
Hey, wait a minute.
There you go.
This one's going fast, but did you look at the other ones? They
Yeah,
were
well, it
going
was pausing.
slow. But they were going slow.
I'll check. So it looks to me like it's moving at some kind of rate. Let's see
Yeah,
this
but
one.
it used to be bonking the wall.
No, they look identical to me.
You're right. I saw it and it looked...
Or I mean, I don't know
first
about
time I
identical,
saw it.
but very close. Right? So it's just that this one is covering so much less terrain. Right?
Yeah, it looks like it's going faster.
Yeah, but slightly. You're
Yeah.
not seeing anything nuts. Okay, tell you what. You're right. Let's test this properly. Okay? To test this properly, what we're going to do is we're going to take this bomb and this bomb. We're going to put them against this wall and make them go right. Okay?
Okay.
So let's remember how to do that. This is a good reminder for us. Okay, so let's stop the code. Let's open our maps in GIMP. Right? So...
Yeah.
Textures. We've got the entity map, we've got the entity info map, we need that one, and we need the map. So we need all of these. Oh, wait a moment. Big problem. That is silly. What we actually want is we want to open the GIMP project. Because it has all three. Okay?
Yeah.
Zoom in a bit. Okay. Grab the pencil. Grab the size all the way down. Awesome. Now, let's worry about the entities first. Okay? Let's also show the world so we know where the entities are. See? That makes it a lot easier to plot things. So we know one entity is over here, and we know this entity is over here. Entity info I'm going to hide, entities I'm going to show. Okay? So red are our bombs. There's one bomb, alright? So what we're going to do is we're going to delete that bomb. Actually, I'm not on any one of them, so I think we're fine. Delete one of them, grab red, hit Control A to select everything. Thanks. And I'm going to put it there.
That's black.
I'm wrong. Alright, so I'm going to put it right here. And let's actually... No, let's leave it alone. Now we need entity info. So entity info used to say something here, but it doesn't anymore. And I'm a bit weirded out by this. So let's try and see why. Hide and hide. Oh, right. Because this information simply tells us which direction the bomb is going to go. But I'm still surprised that the other one has gone.
Also, look, that this was a bomb spawn point.
You know what? I must have pressed delete while I was on this layer. That must be it. So anyway, what did you say? This is a bomb spawn?
This was a bomb spawn and it's not red.
Yeah, but that's because it's just the information. It's taking the red channel and nothing else. You forgot how this works. So in entity info versus bomb versus entities, these are two different maps. Okay?
Yeah.
Worry only about the entities for now. So I'm going to hide entity info.
Okay.
Reds are where the bombs spawn. Cyan are where you spawn. Okay, awesome.
Yeah.
Now, we don't care about this, so we're going to actually show entity info. Okay, now entity info needs to tell us certain information based on the channels of the color. So the red channel is the only thing we worry about. The quantity of red channel. Now remember, it goes like this in a circle.
Yeah.
Well, or maybe like that, I can't remember. But at any rate, it goes from 0 to 360. Okay, so in this case, it's like some kind of dark red, right? I don't remember which color, but if we click on it like this, it'll tell us which color. So let's see. It's halfway red. This means it's going 180 degrees, straight down. In fact, you remember that bomb goes straight down.
Yeah.
Okay, so what we're going to change now is we're going to tell it that this one is in fact going to go straight to the right. Okay, so we need to not divide it by 2, as we did, but we need to divide 255 by 4 to get the quarter. Right, so calculator 255 or 255 divided by 4. That gives us 64. Alright, so we're going to go to 64 and hit OK. Now this could actually go that way or this way, I'm not sure. So we'll find out. Alright, so now on entity information, very important, when I click this. So they're both 64.
Yeah.
Okay, now that could be in that direction, I'm not sure.
I think you turned it. No, it's still the same color.
Yeah, it's very dark, but anyway.
Yeah.
So now we hide everything, okay, and we need to export. Which ones? We've changed the entities and the entity info. So I'm going to hide the world, hide entity info, hit Control-Shift-D to export, and we're going to go to textures, entity map, export, replace, export. Now hide the entities, show the entity info, Control-Shift-E, entity info map, export, replace, export. Done. Now, if we are in game, we should see those two bombs run side by side.
Yeah.
Now they could run in the opposite direction. No, we got it right.
Thump.
Now you see? That one came back. Yeah, now we can't really compare because that one stops that much earlier. Okay, so with the next cycle, maybe they'll be more or less aligned. Let's see. Slightly. Okay, let's see if they go together. No, they won't. One of them will go faster, but observe. Yeah, they move very similarly.
Yeah.
See? That's more or less the same speed. It may not be perfect, but it's darn close.
Yeah.
So I'm happy with that. That's okay. All right, so we fixed the problem. Now they move at the same speed.
Mm-hmm.
And they detect the walls and everything like that. How far from the wall does that stop? So that one stops quite a bit further from the wall because of that 0.5.
Yeah.
So we need to take a risk. What do you want to do? Do you want to try the normal instead, or do you want to try the reflected angle? Rather, not the reflected angle, but the opposite from the collision. Because this is the opposite from the collision, which in this particular case, by the way, is the normal, right? Because you look at my sword here, right?
Yeah.
If I'm pointing straight, this is where my raycast hits. So the complete opposite of it will be this way, which is also perpendicular to this wall. If this wall is like this, the perpendicular is that way, right?
Mm.
So that's the normal. All right.
Okay.
So in this particular case, normal and the other one are the same.
Okay.
In this particular case, though, they're not. Right? So let's check. Gosh, I need to go all the way around. Who designed this? Who's the evil person?
You.
Oh dear.
And me, but anyway.
Okay, so the bomb is going in this direction, right?
I
So
saw
it hits
a wall error.
it hits the wall.
I saw a lot of wall errors.
They're not errors. The walls are randomly rotated.
Oh.
So it goes at this angle, right? The opposite of this ray is this,
Yeah.
right? So it's multiplying this by 1. So in this particular case, it looks like it's actually hitting the wall. It's not, but it looks close because of the
Yeah,
angle.
I can see the shadow is just making it a little
Now,
hard.
the other alternative would be to use the normal. Now, what's the normal of this? The normal of this is this, perpendicular to the wall,
Yeah.
right? So we could use this and push the bomb up by that from the point of contact. This may work better and be less risky, generally. So let's go with this solution instead, as
Okay.
opposed to the one we've got. All right. So that solution is
Right
right
direction dot normalized.
ePause. That's the one. So hit point. You need the
You said hit point. Oh.
right here. Hit point. Hit the point minus direction normalized. That's not what we want. What we want is hit point plus, and now say hit dot normal times 0.5, which is half of our bond.
Yeah.
5f. Save. And now it should be that both the bombs stop when they hit the wall. In this case.
Okay.
We need to be careful not to make stupid cases when we design our levels. See? There you go. See? It's hitting the wall.
Yeah.
Just like us. So it's about as thick as us, so technically, yeah, it looks exactly the same. Right?
Yeah, except that one is green and doesn't have a sword.
Sure,
Not
whatever.
green, blue.
Oh, that one looks like it's inside the wall a bit. That
It's
would
okay.
be odd though. I don't understand why. No, it looks fine. Looks
Yeah.
perfectly fine. It's the shadow fooled me.
Yeah.
Yeah, so this looks better, right? Generally, it looks like it could be a better rule to have.
Mm.
But technically, we would need to do all sorts of tests. But that's okay. We'll live with this particular situation. All right. Now, let's move on with important stuff. Important stuff that we need to do next is we need to turn the bombs aggro.
What does that mean?
They need to become aggressive.
So they
So
follow you when.
that's right. So at the moment, the bombs are just sort of chilling, right? They don't care. Well, we need to make it so that when you're close enough, they notice you and they go aggro and they start chasing you.
Mm-hmm.
Okay?
And their speed gets bigger,
The speed gets larger,
faster.
but also how they'll chase you, that's not obvious. Because if they chase you perfectly, you're in trouble. If their speed matches yours, you could still be in trouble. If it's higher than yours, you're in definite trouble. So there's a bunch of choices that we need to make here. Because I would like it for the bomb to chase you, to start chase you, and start going like, hey man, I noticed you, I'm gonna chase you now. Okay? There's another thing, by the way, we should do, and let's do it right away, is decide where the camera goes. Because the camera is now really close to the player. Okay? And it's kind of meh. Right, so I don't remember what the sides where the camera goes, but I think we put the camera as a child of the player. That would be my bet.
Yeah,
Yes.
we did.
In structure. Oh dear. No, we don't. No, we don't. The main camera is simply following. Maybe we don't even change this. But 20 could be. Uh-oh. So I can't change that to 20. It'll force it back to 10. Aha! Because the camera manager has a distance. Okay, so we're gonna, for now, simply change the distance to 20, hit play. Okay, so now your little fella is seen from quite far, and now we can see that the bomb can get aggressive from pretty far. Now,
And that the grass is going crazy.
yeah, it's going crazy because of the level of zoom out, but still, we have a bit of a problem with the way the grass is designed. We're probably gonna have to revise it. Okay, but or simply just change it to a single color and put some like dirt like the one we have on the dirt, because I think the dirt looks quite good.
Oh.
Even from here, right?
Yeah, I see.
The
Also looks very good rotated.
yeah, the grass we're starting to lose detail already, and we have a bazillion triangles for no reason, right? So we can probably get rid of that. At any rate, now let's say the bomb. First of all, it will decide how far you must be to notice you. So let's say it's here, for example, right? So whatever this distance is, say 5 or something, I don't know, right? Then what it's going to do is change its behavior, right? So it needs to do some kind of like, I'm going angry, and then it needs to start chasing you. So it needs to give you a bit of warning that it's going angry. Okay?
Maybe it will.
Shake a little or whatever, but again, all of that will be done when we have a proper model. For now, we only have this. What it'll do, it'll stop, change colors, for instance, say go red, right? And then start chasing after you.
Yeah, and will it chase after you? What's your idea? Will it chase after you forever?
I don't
blow
think
up?
so. I think it should start getting ready to blow up and eventually explode.
And if it hits a wall, it'll explode.
All right, that sounds good to me. Yeah. So when it chases you, if you manage to do this while it's chasing you, it slams into the wall. it explodes.
It's like a bullet bill.
Yeah, that sounds like a good idea.
I was thinking of Super Mario Odyssey.
Yeah, I know. Well, bullet bill is ancient. I mean, we've had it in Super Mario Galaxy. The bullet bills chase you too.
Yeah.
Okay, so let's see here. So we got hit control and there we go. So start patrol, stop patrol, patrol routine, etc. We've got the aggression routine right here.
Yeah.
So let's begin with void. Start aggression. 2 S's. No, you put the G's correctly and the S wrong. Start aggression. And then void stop aggression.
Coroutines.
Yep. And then you want the I enumerator aggression routine. 2 down. Aggression routine. Save. Alright, so we got the aggression routine. Start aggression, stop aggression. So the first thing the start aggression does, as usual, copy, paste,
Is
semicolon, semicolon. Right. Then it'll do something else. Now, this one, you should remember how to check if a routine is running and then stop it.
well, we don't have the coroutine.
Yes, we do. I can see it from here.
Well, it's here, but we don't have it up here. Oh, yes, we do.
Go ahead.
I forgot to read.
Yeah, reading helps.
Yes, a bit. Anyway.
Top tip for all of the coders out there, reading helps.
If this
Mm-hmm.
is not no, then how do you destroy it? What's the function?
Stop coroutine.
Stop coroutine.
Open round and feed it the coroutine, which is paste. We've already saved it.
Oh
there.
yeah.
Paste, close, semicolon, save. Alright, now you can start the coroutine. So paste again equals start coroutine and then the name of the routine.
Yeah.
Mm-hmm. Open, close round. Close again. Semicolon. Now, does our game manager have a reference to the player?
I think so.
He does.
Yeah.
So we can
Player,
go there.
player.
Okay. So that's how we're gonna go find it. So inside the enemy bomb, the first thing we're gonna say is our target. We don't need to. We can go get it from the game manager every time. So what we're gonna need is we're gonna need a move toward. We're gonna need some kind of rotation.
And
Yeah, so the bomb's gonna have to look at the player at all times. So just say while true. Save. This means do forever, right?
yeah.
While it's true, the first thing we're gonna do is we're gonna say transform dot rotation equals we need the direction. Quaternion dot look rotation. You could use look at, but I hate it. Dot look rotation.
What does look at do?
Look at is a transform class function that turns your forward directly to a certain other transform.
Oh.
Yeah. Anyway, so quaternion look rotation, it uses look rotation. Open round. And now you need to feed it a forward, right? So the forward is going to be the position of our player minus our position. So no, you need to go to game manager.
Oh yeah.
Game manager dot player dot script dot player dot transform dot position.
Oops.
Script. Yeah. Dot player. Dot transform. Dot position.
That's a lot of dots.
You're digging through its structure. Minus transform dot position. So the position of the player minus ours.
Yeah.
What does that do? On a vector 3.
Well,
You don't know. Haha. So I'll tell you.
yeah.
Alright, so if you have two, and now I may even be wrong on this, but because I always forget literally every time, so because I'm a bit daft. But here, there's a point in space, there's another point in space. Right? This is our player, this is our bomb, suppose. Okay. Now the player has a position which is defined by a vector 3, right? X, Y, Z.
Yeah.
This also has a position that's defined by X, Y, Z. In order to get, okay, this vector over here, a direction vector, okay, you need to make this position subtracted by this one. If you do vice versa, this subtracted by that one, you get this.
You're going to get the player going to the bomb.
That's right. Right? Now, I may be wrong, so I may be doing it backwards. I know I'm almost always wrong, so I almost always get it backwards because I forget. But that's okay. Maybe if I did, we'll fix it. So transform dot rotation. So this, we just give it the rotation for now. Okay? And now what we're gonna do is we are going to go in that direction at a certain speed. So it will be transform dot try translate.
New function.
I'm not sure. Hop around.
We'll translate.
Vector translation moves the transform in the direction and distance of translation. So vector 3 dot forward. And then times time dot delta time. Well, do fixed delta time. Do fixed delta time.
Okay.
Cheaper. Times.
Speed.
Yeah, speed, but it's called aggression speed or something. Just type speed, you'll find it. Speeds. Yeah. Square bracket
The
1.
second one is
1.
that one.
And now close the bracket. And semicolon.
There.
Okay. So now one more thing we need, because otherwise our coroutine is going to explode. It's going to be an infinite loop, right? What you need to do is you need to tell
return.
it. No, yeah, well, you need to yield return.
Yeah.
So yield return no, and you wait for fixed update. Open close round semicolon save. All right, so we'll wait for one fixed update and then do it again. Now, this needs to be started. Okay, when it starts, by the way, to start the aggression, you need to stop the patrol. So stop patrol. Otherwise, they'll conflict. Open close round semicolon.
Yeah.
All right, so that's good. Now we need to have an information as to when we're going to start the aggression. Okay, so we're going to need to test that. There's no other way that I can think of to test that other than using either A, another coroutine to test, or B, a loop, an update loop or a fixed update. Let's use fixed update. So here you can do void fixed update. Remove this.
I
Save.
finally didn't type.
And here you can go if. And here we're going to test the distance. So we're going to say vector3 dot distance. Dot distance. Tab. Open round. Between transform dot position. Dot position. Comma. The player. So go find him. Yeah, that's too easy.
That's too easy. Player, so I need to go game manager. Not script. Oops. Dot player.
And then player is a player class.
So
We can't. To get position, you need which class?
transform. dot position.
Close round. Now wait a moment. Do we have a distance? Detection distance, we do. So we say is lower or equal to detection distance. Just keep typing, you'll figure it out. There it is. Close round, open a squiggle, hit enter twice, close squiggle, save. Right, and now we're gonna start aggression. Copy, paste, open, close, semicolon, save. Now, before we start the aggression, let's do a few things. We're gonna want access to our own material. Okay, we're gonna want access to our material. So, how do we do that? Private mesh render MR semicolon. Now here in setup, we're gonna set it up before start patrol. Go MR equals, and now I don't remember. So we're gonna go to our excuse me, to our enemy bomb. Has a structure and a model. So structure model. Transform.find. Open round. Quote. Structure, capital S. Slash. Capital M model. Model.
That will not work.
Model. Close quote, close to the round bracket. Dot, no, dot. What are you missing?
Get component.
Yeah, of what type?
Mesh render.
Yes.
Oops.
Oof, that went poorly. That went very poorly. Open, close rounds. Alright. Now,
Finally got there.
to do this, what we're going to need is we're going to need a we need a reference to the main material. No, we don't. No, we're simply going to change this material. That's it. Okay?
Okay.
So we're going to simply change this material. We're going to go yeah, so right here we're gonna do another while. Well, first of all, create a float passing time. Passing time equals 0. F. It's a float. Okay, yeah, pretty good. Enter. While passing time lower or equal to 1. Lower or equal to 1. 1f or B1. It's new. Close round, open squiggle, hit enter twice, close, save. Alright, so first of all we're gonna have to decide how long we're gonna wait for. So for that we're gonna need a new serialized field private variable. Private float, and call this one aggression weight.
Finally, you
Semicolon.
spelled it right.
Okay. Now there's another thing I remembered, but we'll worry about it in a moment. So aggression weight go equals to F. So it's gonna wait for 2 seconds. Save. Okay. So here we need to wait for those 2 seconds, and in those 2 seconds we're also going to do something. We're going to turn the color to a different color. Now the different color should probably be here. So let's do serialized field, private color. Actually, do an array of colors. Private color array. And go aggression colors.
by 2 colors.
You'll see. So the first step is to turn into this.
Is it going to flash?
No, but we said that it's going to blow up after a certain distance, no?
Yeah.
It's going to blow up either after a certain distance or when it contacts something, right? So first we're going to worry about the distance. So let's add another serialized field. No, let's do it up here actually. So serialized field, close, private, float, max aggro distance. Aggression, max aggression distance. And give it a default value of 15. F, it's a float. Detection distance, give it an equals to 5F. Save. Okay, so the first step is stand still and turn this color, right? And turn the first color of the 2 aggression colors. Then as it walks, it turns more red or something. So let's say it's going to be yellow and then red. At this point, let's give it the 2 different default values. So you go equals, new, color, 2 of them. No, square bracket. 2, close, open a squiggle. New, color. No, wait. Just say color dot yellow. There it is. Comma. Color dot red. Close the squiggle. Save. So that means that it's always going to have this default value. You can still change it, but this is the default value. All right. So we have the aggression weight. We have the aggression max distance. Should we call this aggression max time instead? So for how long it goes as opposed to how far it goes. I like distance though, because it'll give the player a certain idea as to how far they need to run before the bomb blows up. But time probably makes more sense because the bomb sort of fries for a certain amount of time and it goes kadoosh, something like that. So perhaps instead of distance, let's call this one time. Capital T.
There.
Or TV. Save. Okay, so let's use aggression weight first. All right, so here you're going to say passing time plus equals time dot fixed delta time where we go, multiply divided by the weight, whatever we called it, not weight,
that weight,
the aggression weight, just type aggression, always capital, very important on all variables. Okay, now here do I yield return, don't do anything, copy, paste. There we go.
Good thing I hadn't done it yet.
And here what you can do is you can say mr dot material dot set color or set color open round quotation mark underscore color with a capital C, close the quote, comma, color.lerp. We're missing something. Type color, S color equals, copy all of this, paste it here, close this round bracket, semicolon, change the S to a G. So we get the color first, okay, then we're gonna lerp, open round, S color, comma, and this one is going to be aggression colors 0. Square bracket 0, comma, and now the control value, which is passing time.
Yep.
Close the round. Semicolon. So now first it goes aggro, then it starts running after you. when it starts running after you, we move it. But we're also going to start counting the time. Okay, so let's reset passing time to 0 here. Passing time equals 0. F. Every time. It's a float. Okay, now here we do this thing. Okay, but before we do it, we're going to say passing time plus equals time dot fixed delta time without any multiplications. Fixed delta time. Okay. Now I've got an idea now that I think about it. It's where is this expected? Oh yeah, one extra bracket. You close the lerp but not the set color.
Yeah.
We could do the same as this actually. So copy this criterion, put it right here, and divide this time dot delta fixed delta time by the max aggression time. So copy that, paste, save. Okay, so that's pretty good. And now here just type destroy game object. Yeah.
To
Yeah, close right, semicolon.
destroy yourself, which is the bomb.
That's right. So the bomb will simply disappear for now, but that's okay. It's a good start. Okay, so we've got the colors. Now one thing that also needs to happen while this happens is exactly the same. So copy this, paste it here, and this one is now copy this, paste it here, put a 1, save. So the bomb's gonna start boiling towards red. When it reaches red, kadoom, it blows up.
Now we need to code the wall.
We'll worry about that in a moment. Let's start with this and see how it goes. Okay. So good, we got all of this in. Now we need to take a look at the bomb and all of its values and everything. Now one important thing that I want you to remember here, we're changing the material. Okay, what does this mean? We're not changing the shared material, we're changing the material. This will create a new instance of the material immediately and separate it from all the other bombs, which is very convenient for us. Okay, so detection distance is 10. Max aggression time is 15. The speeds are half and 1, right? I would almost say, let's do 1.5. Let's make it a bit faster, so the player needs to run away. This is fine. Aggression wait 2 seconds, so it gives you 2 seconds to start running away, and then it goes.
Yeah.
Alright, so save.
That's a test.
Let's try it out. There, you do the honors.
Okay.
It may or may not work, just saying.
Do the honors of test. Waves actually look like waves.
Oh!
Oh. Hey.
And it's not moving. Wait, stand still, stand still.
That one is. Look, they're trying to.
What, they're going all mental? How's that work?
Look, they're going through the wall. Hey. Move it. Look.
How broken is this? It's pretty broken. Okay, give me a second. I want to see why they all went aggro. Should be only one, all of them, or did you approach all of them? So
I got pretty close.
So I'm staying quite far.
That one's.
So it's gone yellow. Now it has theoretically 15 seconds before it explodes. So let's take a look and wait. Let's just patiently wait for it to blow up. But I'm not seeing that increment.
It's not. 15 seconds surely passed.
I don't know about surely, but yeah, probably. Okay, anyway, the detection is working. It's turning there. Passing time is 0. Passing time. It increases the time by fixed delta time divided by max aggression time. Wait a moment, let's check if there are errors. No. So divided by max aggression time. Then it goes by passing time. That's good. Transform rotation, look rotation towards the player, at least in theory. And then it translates again, at least in theory, in that direction. And then it waits. And the passing time should keep on going up. That's very strange. So
should we debug?
wait. Well, but debug what? You need to think first. Okay, so the change of color isn't even happening. This must mean the passing time isn't going up somehow. At least not meaningfully. But I don't get it. It's looking correct to me. Fixed delta time divided by max aggression time. Aggression colors is supposed to be different. And it is. The second aggression color is definitely red. This also works perfectly fine. So what's going on with max aggression time then? Did I put like some ludicrous number like 100? No, it's 15. Okay, let's change it to 3. So in 3 seconds it should blow up, in theory. Right? If you still see it being yellow, that means it's actually not going aggro. Also, I think it's going aggro a bit too far from us. Yeah, definitely. We need to reduce the distance. Okay, so it's definitely gone yellow.
3 seconds passed.
3 seconds guaranteed passed. So it's not happening. This is not happening. So passing time. Aggression color, yield return. It's like we never exit here. That seems weird. Type debug.log here. Just quote here. Here. Close.
I thought here meant like here.
Here means here still. If you could close that quote so we can carry on, that would be great. Jesus Christ on the back. Alright, so that's good. She finds it amusing. We need to reduce the detection distance to 5, so we need to get closer. We also should check for something else. The detection distance to check if there's a wall between us. That was 5? Okay. See, here never occurs.
Mm-hmm. Means it never gets
That's very confusing.
passed.
That's very confusing to me.
Do we never call aggression routine?
No, obviously we do, because we're turning yellow. But
Yeah.
I don't... Oh, right. What a utter fool.
What?
We call aggression routine a bazillion times. Because we weren't aggressive. So, yeah.
Oops.
So here you need to go, if not aggressive. So if not aggressive... I knew I forgot something. No, exclamation mark. Come on. Don't be an idiot. Aggressive. Okay, close. Open. Wait. Save. Okay, so if not aggressive, start aggression. Start aggression should go aggressive equals true. Alright, and this should now work. I don't think we need this. Save. So the problem is this was being called endlessly.
Yeah.
Like restarted all the time.
Yeah, so that it never managed to get to that.
Right. Now
Red
max
part.
aggression time is 3 seconds, so the bomb should blow up right away. So 5 is still quite far. Oh no, it's pretty good.
Oh, but Jason.
Oh, boom. Alright, so that's not too bad. 3 seconds actually is pretty good. 15 seconds is probably excessive. So let's go to 5 and let's increase the speed. I want the speed of that guy to go like ridiculous. Now, what's the player's speed?
I think it's 1? No, we had made it much faster. I seem to remember. That's it.
5.
5.
Okay, let's make the bomb speed 6.
Okay.
So that the bomb, like, it gives you a bit of warning. Watch out. I'm following you now. And then he goes like, okay.
And if you're a potato, then you won't move.
Yeah, you just wait there and then get killed.
Yeah.
Because you suck. 6.
Or you don't, or you've never played the game before and you can't read, and no one has told you about it.
Hello! Hello! Oh dear! Ah! Okay, that doesn't look like 6 at all.
Let's make it faster.
Yeah, but that doesn't make sense. Let's see what's happening here. So, is it chasing you forward? Yeah, time, delta time, speed's 1. I did change the speed. At least I think so. Speed, it's now 6. I'm gonna put 60 just to see what happens because I don't understand.
It looked like it was going the same speed as time it.
Oh!
Bye.
Boom!
It
Okay, so 60 clearly worked. So it must be because... So normally we use like lerps. We could use a lerp, though. I quite like this. Yeah. Okay, so wait a minute. Change the 60 to a 10.
That was way too much.
Yeah, but clearly. I was just experimenting. No. Ow. Wait a moment. So now I've changed it to 10. And it still feels like 60. Maybe you need to click away. It's possible. I don't know, right? It seems very strange because now it felt just as fast as before. And it clearly wasn't right.
Yeah.
Like it should be 6 times slower. Let's see. Oh.
That looks very funny.
It does look a bit funny. So 10 is too fast. So I think 6 was fine. It's just it never applied. So you do 6, hit enter, press back, test. Alright. So I want it faster than me, but just a tiny bit. Not like, I'm a rocket! Run, Forrest!
Death. Actually, he didn't get killed. There should be a little area around it that hurts you. There's a bomb in Smash Ultimate. You hold it out like this, and it has a huge area of explosion.
Area of effect is what we call that.
Effect.
AOE. Alright, so let's give it a speed of 5.5, I say.
You got away.
Yeah, 5.5 I think is cool.
It's kind of late.
No, detection distance. Actually, detection distance feels too close to me. So let's try 7.5. And at this point, let's leave it there. Max aggression time. That feels long, so I'm going to try 4. So this is very much about feeling now, right? You're making some careful decisions. The speed at which it walks normally. Let's try 1. Will you stop jittering?
Sorry.
Bloody children. Fidgeting and all that. Alright, so. Oh, that's too fast. Oh, hello. No! No! Leave me
alone. Look, the other one got... the other one went through the wall.
I'm gonna sword you!
It exploded still.
It did.
It also went right through the wall.
The detection distance is good. I like the detection distance.
It went right through the wall.
I saw.
Oh.
Yeah, we don't have any the collision detection. What do you expect? You said it's late, right? So we need to stop anyway. Now let me see here. 7.5, 6, 1 is too fast. So we're gonna keep on moving at 0.5 speed. Maybe 0.6. I don't know. It just feels a little slow. Max aggression time 4 seconds still feels like much. Let's do 3.
So now it follows you for less?
Yeah, follows you for less time.
Like it's like, ha ha ha! I'm going to have some fun.
Oh dear!
What's that?
Oh dear! Oh dear! I hate you. Okay, and this is gonna go, hey man. Oh no!
And he's gonna go, hey, I'm
no, two of you. No.
Why do you think?
Winning.
Except you got hit once.
Maybe. We don't know what the AOE will be.
They don't spawn back.
They don't spawn back, which is another problem. So many problems. Well, that'll be sufficient for tonight.
For the recorder people.
For the recorder people, yes. For the recording. YouTube folks, we'll see you again next time. Bye.
Bye.